The next subject is digital manufacturing, or 3D printing. Let's watch our draw shop video.
3D printing, also known as additive manufacturing, is the process of printing layer by layer any three-dimensional object based on a digital file. In a 3D printer, one or more print heads extrudes a small amount of materials in precise locations to build objects point by point from the bottom up. Today, we can 3D print in full color and in over 250 different materials ranging from titanium to rubber, plastic, glass, ceramic, leathers, and even chocolate. 3D printers can create very complex structures of mixed materials and print almost anything, from jet engines to jewelry to houses to even medical prosthetics. 3D printing transforms the entire manufacturing process. Customization and complexity come for free, and large-scale custom manufacturing is now no problem. Additive manufacturing also saves tremendous costs, requiring as little as 10% of the raw materials expended in traditional manufacturing and eliminating the need for inventory. Ultimately, 3D printing dematerializes, demonetizes, and democratizes manufacturing and turns us all into creators. If you or your customers are in the business of making, well, anything, 3D printing is on the road to disrupting your industry and your business.
Again, Carl Bass, CEO of Autodesk, sends his apologies. The laws of physics and gravity won over his best intent. But so much a pleasure to have a dear friend, someone I love greatly, Avi Reichental. He is the CEO of XponentialWorks and is really helping to move forward exponential technologies. For 12 years, he was the CEO of 3D Systems. I was proud to be on his board and has been chairing our digital manufacturing track at Singular University. Please welcome Avi Reichental. I'll give this to you. I'm going to start with a question. I remember when we were on the 3D Systems board and I was in the midst of what was going on and I was thinking to myself, wow, I mean, the innovation is like, we've like invented everything. Is there really going to be new innovation in digital manufacturing? And it's been crazy.
And the answer, Peter, is really every day. There isn't a day that I don't get up and something new has happened that has disruptive potential and really opportunities to harvest the upside of that disruptive.
If I could, let's start with a couple of metrics. How many materials, how many colors, how big, what is the sort of the box around about digital manufacturing today?
It's open-ended. Material and chemistry have evolved so much that we're looking now at probably north of 500 materials. 500
different materials.
The ability to print in full color in millions of variations, and a real expansion into completely new areas of construction and aerospace and healthcare. Let's take a quick look.
Please.
And this is some of the work that Carl Bass is doing. Sorry, he's not here. He is digitizing parts of the universe to learn how design should really work. So this was a project to design a vehicle, to digitize a vehicle, put hundreds of sensors into it to learn how a chassis would be designed by a computer. I mean, remember that the most incredible structures have been patented by nature.
Yes.
And we've been mimicking those incredible structures in robotics and in transportation and in so many other areas. What if a computer could teach you how to do that in a way that also optimizes the topology for lightweighting?
So I think this is called generative design.
Generative design.
And I believe what they did is they built a car in the shop, they instrumented it, and they went and drove it on the desert and actually collected all the data and then gave it to effectively a machine learning model and say, given these stresses and strains, how would you design it for strength and minimum weight?
Yes. And there's a lot of topology optimization here, which is kind of the ultimate way to free up 3D printing to deliver to advantage, because today we're still designing traditional geometries for 3D printing, and with 3D printing we really need topology optimization, and this is a key opportunity that large and small companies are harnessing, including, by the way, George Votis, who's right here, and myself, that just funded a new startup in topology optimization called Parameters. So
you gotta let me into some of these deals.
Can make a difference. The next is automotive, and automotive is really, really important in terms of 3D printing and topology optimization, because the future of performance, lightweight structures that perform at superior performance and energy saving is the future, and the ability to create distributed manufacturing anywhere with mass customization and energy efficiency.
We're seeing the 3D printed cars here.
Yes. The next is all kinds of artisanal activities. This is one of the latest examples from MIT, printing in glass. But think about also printing in pottery, printing in garden fixtures. Think of printing in food. All of these areas are moving at lightning speed, and the glass particularly can open tremendously new opportunities in design, in interior design, in construction, etc.
It's beautiful.
If you look at the next one after that, we talked a lot about construction of buildings over the years. You know, we looked at countercrafting and all kinds of other capabilities. This is the latest. It actually happened in Thailand. This is a full-size house being 3D printed in 10 hours.
Wow.
And the speed and performance and intricate design that can be achieved now just boggles the mind. And this is at least, Peter, a 10x improvement over what we saw just a year ago.
That's awesome.
The next is an early-stage company out of Israel called Massive It. This is
That's a cool name, Massive It.
Non-structural materials, but if you think about displays in malls and theaters and entertainment, this is the machine that will make you life-size objects for advertising, for promotions, for trade shows, for amusement parks. And it's a completely new hybrid of technology between photo curing and additive layering manufacturing that just makes giant parts.
So this is the future of the movie industry. And
absolutely, because it makes it at lightning speed and it makes giant size parts. When you look at it, this is life-size components.
Oh my God.
Take it to the next level. We're going to talk about convergence of robotics and 3D printing and AI and generative designs. This is one of the first industrial strength direct metal machine that is combining additive and subtracting by depositing powdered matter in what's called laser cladding and using 6 axes of machining in the same machine to completely finish a part to commercial strength at convincing scale. So this is really the industrialization of digital, convergence of digital fabrication in a box.
Right.
In a way that scales as a machine tool.
So you're 3D printing final metal products.
And finishing them in a CNC machine.
In titanium, in any metals?
Any metal that you want.
Wow.
In any metal that you want. And the Holy Grail, printed circuit boards. This is another Israeli startup, by the way, surprise, surprise, called Nanodimension, that is bringing to the market the first 3D printer that can print fully functioning printed circuit board.
Fully functioning
printed circuit board.
So you can iterate on a circuit board like
in hours.
Wow.
In hours. They're at CES, and I was blown away to look at that technology.
Oh my God.
It's a real deal. My former company, 3D Systems, is integrating robotics and continuous printing, so you can see that you can literally now take endless Z direction parts out of a very shallow vat and photo cure them. And of course, We talked about Nexa 3D.
Which is revolutionary,
10x
yeah.
Improvement in size, accuracy, and speed. And by the way, thank you to the community. We have, as of this morning, more than 50 pre-orders for Nexa 3D.
Great for you guys.
With,
awesome.
George leading the pack with 30.
Yeah.
So, that's it.
Wow. So, I mean, I mean, every time I think, how could it possibly get better, faster, cheaper, it does. I mean, it's just
at lightning speed.
At lightning speed.
At lightning speed.
That's extraordinary.
And here the oxygen is not just infinite computing power, but connectivity, cognitive systems, learning algorithms, robotics. It's all coming together and catalyzes this convergence and creates really amazing opportunities, not only for manufacturing capability and learning and designing, but really for completely new disruptive business models.
So if I just close on one question, and it's a hard question, but 5 years from now, given this extraordinary rate, I mean, this stuff is all like in the last year. I mean, what's conceivable? Like, what's a fantasy moonshot in 3D printing 5 years from now?
I think the fantasy moonshot is in creating finished products that are mass customized at convincing scale and disrupting retail, disrupting aerospace, disrupting automotive, disrupting the construction industry. We have enormous opportunities here for the first time to not just create new markets and new opportunities, but begin to look at traditional business models and disrupt the entire supply chain.
Wow. We'll talk about a huge amount of implications in just a few minutes. Avi, thank you so much, pal.
One day we need to do something
about this. I'll just tell you. I call you every morning and ask you, what are you wearing?
I wear the same shirt every day.